All right, so let's think about what the derivative of the graph sine of x would be. So we've done some of these before, so it's useful to find out when the slope of the tangent line is 0. So there's the slope of the tangent line is 0 at pi over 2 there. And the slope of the tangent line would be 0 here at 3 pi over 2. So putting them right below. Then if I took a tangent line, drew it right here at 0, I can see that that would be a positive slope. So it's positive slope coming to pi over 2, positive slope, because if this is the derivative, right, this is the slope axis. All right, and so then if I'm drawing a tangent line here, say at pi, the slope would be negative, so that means it's below the x-axis. And then if I was to draw a tangent line here, it'd give me a positive slope, so it'd be above the x-axis. So this looks a little bit like the cosine graph. Whoops. So it actually is. It actually is the derivative of the sine graph is the cosine graph. And that's a little bit intuitive there. If I use the definition of the derivative, this is the definition of the derivative, right? So if I used x plus h inside of sine, then I used identities here that you will never need to know, but just showing you if you put this, expanded it out with the sine, and then I broke it up, and I used these two facts here, so just lots of trig identities and a couple of facts that I'm just presenting to you. I'm not telling you about them, or we're not going to use them. Then I find out by using algebra, it gives me cosine. So just showing you algebraically it works in the definition of the derivative. Here's another one we could look at. So this is tangent. Instead of using identities, let's just use the derivatives of quotient rule on this. So you know tangent is sine over cosine. So if I did low d high minus high d low, and the derivative of cosine is negative sine, square the bottom and off you go. So I see I get two negatives here, so I get sine squared. Well, you know that sine squared plus cosine squared is 1, so I get 1 over cosine squared. That's the same as saying secant squared. So that's it. That is the derivative. So these 6 trig functions you will need to memorize. So I'm not going to go through any more math enrichment or proofs of them. Just tried to stack them in ways perhaps it could be useful to memorize. So sine, tangent, and secant are all positive. Cosine, cotangent, and cosecant, they all start with the letter C. All of their derivatives are negative. Something that could be helpful for you. Tangent and cotangent, their cotangent's 1 over tangent, correct? They both have derivatives that are squares. Then secant and cosecant, so secant's 1 over cosine, cosecant's 1 over sine. They both have 2 trig functions as their derivatives. So a little bit of helps, hopefully, to memorize. You're just going to have them memorized all year long. Really, really important. All right, so let's just take a few derivatives. You do not need to simplify at all at this point. So in this one, I just want you to recognize there's product rule. So first, d second, derivative of cotangent is negative cosecant squared, plus cotangent, and then derivative of root t, which is 1/2 t to the negative 1/2. And that's good. All right, let's finish this little page here. So example 2 here, I've got a quotient. So I want to use the quotient rule on this. So just take a moment here. We know that a is a constant. So if I'm just taking the derivative of a, I get 0. If I'm taking the derivative of a constant times a function, you carry that constant line along and you take the derivative of the function. So if I take low tangent, d high, derivative of a plus b secant would just give me b secant tangent, because the derivative of secant is secant tangent, minus high d low. Derivative of tangent is secant squared, and square the bottom and off you go. So even though I say secant tangent, it is secant of x, tangent of x. They both have their own angle, so be careful about that. Example 3 here, if I have this is my function, take the derivative, so 4 times cosecant, that's just a constant times a trig function, nothing much there. This is product rule. So take the derivative of cosecant, you get negative cosecant cotangent, carrying the 4 along. And this you could choose to do how you want, lots of different ways. I'm going to pull the negative 3 on the outside and then worry about taking the derivative of x times sine. So first d second plus second d first. Derivative of x is 1, remember. And then I just multiplied the negative 3 in. All right, one last one on this page here. So this is my function. So notice theta is like your x. So first d second. So derivative of tangent is secant squared of theta. Derivative of negative theta is just negative 1. So think of this as just negative x. Derivative of negative x would be negative 1. Plus second d first. And that's it for that page.